When converting a two-family house into a single-family unit, you'll likely need to upgrade the electrical service. The National Electrical Code, or NEC, Section 230.40, Exceptions 6 and 7, addresses permitted modifications in this scenario. Exception 6 allows you to remove the existing 2-meter box and install a single meter base. Exception 7 permits you to upgrade the service mast to 150 amps and feed the two existing 60 amp panels from the new, larger service. Because the upgraded service will be rated over 100 amps, a main disconnect is required. According to NEC 230.70, this disconnect can be located either outside, next to the meter, or inside the house, before the service entrance conductors enter the building. Keep in mind several additional considerations. Firstly, you may need to upgrade the two existing 60 amp panels to 100 amp panels. This ensures they can handle the increased demand from the 150 amp service. Secondly, verify that the conduit connecting the meter to the panels is appropriately sized. It must be large enough to accommodate the new 150 amp service and the combined electrical load of both units. Thirdly, ensure that the grounding and bonding systems are adequate for the upgraded service and the combined load. Here's a recommended procedure to follow. 1. Remove the 2-meter box and install a single meter base. 2. Upgrade the service mast to 150 amps. 3. Install the main disconnect either outside next to the meter or inside the house before the service entrance conductors enter the building. 4. Connect the 150 amp service conductors to the main disconnect. 5. Extend the service conductors from the main disconnect to the two panels and connect them to the upgraded 100 amp panels if necessary. 6. Carefully inspect the grounding and bonding system to ensure it meets the requirements for the new service. 7. Have the entire electrical system inspected by a qualified electrician to verify compliance with the National Electrical Code. This inspection is crucial to ensure the safety and proper functioning of the upgraded electrical system. The NEC is a comprehensive set of standards designed to ensure electrical safety. It covers various aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. Familiarizing yourself with the applicable sections of the NEC is essential for any electrical work. When upgrading an electrical service, several key factors need consideration. Firstly, load calculation is critical. Before upgrading the service, determine the total electrical load of the building. This calculation helps ensure that the new service is adequately sized to handle the demand. The load calculation should include lighting, appliances, heating, air conditioning, and any other electrical equipment. Secondly, overcurrent protection is important. The service must have appropriate overcurrent protection, such as circuit breakers or fuses. This protection safeguards against overloads and short circuits, preventing damage to the electrical system and reducing the risk of fire. The size of the overcurrent protection should match the ampacity of the service conductors. Thirdly, grounding is essential. A proper grounding system is crucial for electrical safety. It provides a low impedance path for fault currents, helping to trip overcurrent devices and prevent electrical shock. The grounding system should be installed according to NEC requirements and connected to a grounding electrode, such as a ground rod or water pipe. Fourthly, bonding is required. Bonding involves connecting all metal parts of the electrical system, such as conduit, enclosures, and equipment grounding conductors, to form a continuous electrical path. This helps to minimize voltage differences and provide a safe path for fault currents. Bonding should be performed according to NEC standards. Fifthly, wiring methods are important. The wiring methods used for the service conductors must comply with the NEC. Common wiring methods include conduit, cable, and wire in free air. The type of wiring method depends on the application and environmental conditions. Wiring must be properly supported and protected from physical damage. Sixthly, disconnect location is something to keep in mind. The location of the main disconnect is an important consideration. The disconnect should be readily accessible to the homeowner and located in a safe place. The NEC specifies requirements for disconnect locations, including clearances and working space. 7th, inspections are critical. After completing the electrical work, it is essential to have the system inspected by a qualified electrical inspector. The inspector will verify that the installation complies with the NEC and local codes. Inspections help identify potential hazards and ensure the safety of the electrical system. When selecting an electrician for the upgrade, choose a licensed and experienced professional. Check their credentials and references to ensure they are qualified to perform the work safely and competently. A qualified electrician will be familiar with the NEC and local codes and will ensure that the upgrade is done correctly. Also, obtain the necessary permits before starting the electrical work. Most jurisdictions require permits for electrical upgrades. Permits help ensure that the work is inspected and complies with applicable codes. Failure to obtain permits can result in fines and delays. Before starting the upgrade, create a detailed plan of the work. The plan should include a load calculation, a wiring diagram, and a list of materials. Having a plan helps ensure that the work is done efficiently and correctly. It also helps to identify potential problems before they arise. Also, use quality materials when upgrading the electrical service. Inferior materials can compromise the safety and reliability of the system. Use materials that are listed by a recognized testing laboratory such as Underwriters Laboratories or Intertech. These listings indicate that the materials have been tested and meet safety standards. Always follow the manufacturer's instructions when installing electrical equipment and materials. Incorrect installation can lead to safety hazards and equipment failure. The manufacturer's instructions provide important information about proper installation techniques and safety precautions. Remember to de-energize the existing electrical service before starting any work. This is essential for preventing electrical shock. Use a voltage tester to verify that the power is off before touching any wires or equipment. Also, wear appropriate personal protective equipment such as safety glasses and rubber gloves when working with electricity. This equipment helps protect against electrical shock and other hazards. When working with electrical panels, be careful not to touch any exposed wires or components. Electrical panels contain live circuits that can cause serious injury or death. Always use insulated tools when working inside electrical panels. Ensure that all electrical connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to fires. Use a torque screwdriver to tighten connections to the specified torque. When running new wiring, be sure to follow the NEC requirements for wire size, conduit fill, and support. Incorrect wiring can lead to overheating, voltage drop, and other problems. Use the correct size wire for the load and protect it from physical damage. Also, properly label all circuits and equipment. Labeling helps to identify circuits and equipment quickly and easily, which is important for troubleshooting and maintenance. Use a permanent marker or label maker to create clear and accurate labels, and document all changes made to the electrical system. This documentation should include a wiring diagram, a list of materials, and any other relevant information. Keep this documentation in a safe place for future reference. Periodically inspect the electrical system for signs of wear and tear. Look for loose wires, damaged insulation, and corroded connections. Address any problems promptly to prevent them from escalating. Regular maintenance can help extend the life of the electrical system and prevent costly repairs. When working on electrical systems, always prioritize safety. Electricity is dangerous and can cause serious injury or death. Follow all safety precautions and use common sense. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Continuing on from the previous points, consider these advanced aspects when upgrading electrical service. Firstly, surge protection is something to keep in mind. Consider installing surge protection devices at the service entrance and at individual panels. Surge protection devices help protect sensitive electronic equipment from voltage spikes caused by lightning or other electrical disturbances. Surge protection can extend the life of electronic equipment and prevent costly damage. Secondly, energy efficiency is important. Consider using energy-efficient lighting, appliances, and equipment. Energy-efficient products can reduce energy consumption and lower utility bills. Look for products that are Energy Star certified. Thirdly, smart home integration is something to think about. If you are planning to install smart home devices such as smart thermostats, lighting controls, and security systems, consider upgrading the electrical service to accommodate the additional load. Smart home devices can add convenience and energy savings, but they can also increase the demand on the electrical system. Fourthly, backup power is a good option. Consider installing a backup power system, such as a generator or battery backup, to provide power during outages. Backup power can keep essential appliances and equipment running during emergencies. The size of the backup power system should be based on the critical loads that need to be supported. Fifthly, electric vehicle charging is becoming more popular. If you are planning to purchase an electric vehicle, consider installing a dedicated charging circuit. Electric vehicle chargers can draw a significant amount of power, so it is important to ensure that the electrical service is adequate. The NEC provides specific requirements for electric vehicle charging circuits. Sixthly, renewable energy sources such as solar panels are becoming more common. If you are considering installing solar panels, consult with a qualified solar installer to determine the impact on the electrical service. Solar panels can generate electricity and reduce reliance on the grid, but they can also require upgrades to the electrical system. Seventh, demand response programs are sometimes available from utility companies. Consider participating in demand response programs to reduce energy consumption during peak demand periods. Demand response programs can help lower utility bills and improve grid reliability. When upgrading the electrical service, work closely with the utility company. The utility company will need to approve the upgrade and connect the new service to the grid. Be sure to follow the utility company's requirements and procedures. Consider the future needs of the building when upgrading the electrical service. Plan for future expansion and increased electrical demand. It is often more cost-effective to install a larger service than is currently needed, rather than upgrading again in the future. Also, keep accurate records of all electrical work performed on the building. These records should include wiring diagrams, load calculations, and inspection reports. Keep these records in a safe place for future reference. Remember that electrical work is regulated by codes and standards. Be sure to comply with all applicable codes and standards to ensure the safety and legality of the installation. The NEC is the primary standard for electrical installations in the United States. Also, stay up to date on the latest electrical technologies and trends. The electrical industry is constantly evolving, so it is important to stay informed about new products and techniques. Attend industry conferences, read trade publications, and take continuing education courses to stay current. Finally, never take shortcuts when it comes to electrical safety. Electrical work is not something to be taken lightly. Always prioritize safety and follow best practices. If you are not sure how to do something, seek help from a qualified electrician.